Glider 11-1 Cross-Country Soaring. Glider pilots primarily rely on pilotage, navigating by using ground landmarks as reference points. This approach is favored as gliders often can't maintain a consistent course line over long distances and don't typically maintain a steady speed for extended periods. While pilotage is the mainstay, understanding dead reckoning remains important for glider pilots. Dead reckoning involves calculating a heading using true airspeed and wind, then estimating the time required to fly to a destination. Occasionally, a blend of both pilotage and dead reckoning might be necessary for navigation. Using the plotter for distance and true heading measurement top of form. The plotter is a handy tool for measuring distances and determining true headings on sectional charts. For instance, on the Albuquerque sectional chart, using the plotter with the 0 mark set on Portales Airport, Q34, reveals a distance of 47 nautical miles to Bangor Airport, Q54. To find the true heading between these 2 points, place the straight edge along the course line and adjust it until the index hole aligns with the longitude line crossing the course. The outer scale indicates the heading for an easterly component. In this case, the true heading from Portales to Bangor is 48 degrees. If flying the reverse route, from Bangor to Portales, use the inner scale for westerly components, giving a heading of 228 degrees. It's common for beginners to misread headings, particularly mistaking W 270 degree for EO 9 degree, resulting in a 180 degree error. For instance, the correct heading from Portales to Bangor falls between 30 degree and 60 degree, confirming the true heading of 48 degree. A sample cross-country flight. For a triangle course starting at Portales Airport, passing through Bangor Airport, X54, and the town of Circle Back, the pre-flight preparation involves drawing course lines for the 3 legs and determining the true and magnetic headings for each leg. The first leg covers 47 nm with a true heading of 48 degree, adjusted for a 9 degree east variation to give a magnetic heading of 39 degree. The second leg spans 38 nm with a true heading of 178 degree, adjusted to a magnetic heading of 169 degree after considering the variation. Lastly, the third leg also covers 38 nm, initially at a true heading of 282 degree, adjusted to a magnetic heading of 273 degree due to the 9 degree east variation. Understanding wind conditions is crucial. The forecast indicates cumulus bases at 11,000 MSL, with winds aloft at 320 degree 10 knots at 9,000 MSL and 330 degree 20 knots at 12,000 MSL. During the flight, these winds will impact each leg, providing a direct crosswind on the first leg, a weaker crosswind on the second, and an almost headwind on the third. Pilotage, navigation by landmarks, will guide the flight. Landmarks along the legs include highways, railroads, towns like Clovis, Bavina, Friona, Muleshoe, and power transmission lines. Airspace details, like Class D around Cannon Air Force Base in the Bronco 1 military operations area, are important considerations, especially for potential military traffic in restricted areas. During flight, adjusting to weather changes may require altering the planned route. For example, if unexpected weather arises near the third turn point, circle back. Altering the course to return directly to Portales might be necessary. Calculating this change, with an estimated 37-mile distance and a heading of around 240 degree, adjusted for variation, will guide this deviation. Decision-making during flight remains crucial. Weather conditions, terrain, and landing options must be constantly evaluated. In the event of deteriorating weather, adjusting the course and evaluating available landing sites becomes critical for a safe return or off-field landing. In summary, navigation, weather evaluation, and decisive actions are essential throughout the flight to ensure a safe return to Portales or a secure off-field landing, all while considering the constantly changing conditions and available options along the way. Utilizing GPS for glider navigation. GPS systems, available as portable handheld units, offer a convenient aid for navigation in glider flying. These units provide distance and heading to specific points, accessed through an internal database of waypoints, and continuously display ground speed. They can also calculate the headwind component by subtracting ground speed from known true airspeed. Additionally, many units feature a moving map display showing the glider's position in relation to landmarks and the ability to mark spots for future reference. However, while GPS units simplify navigation, pilots must avoid over-reliance on them, as excessive focus inside the cockpit can distract from critical tasks like flying the glider and scanning for lift. Over-reliance can also lead to neglecting external visual scanning for other air traffic. Since electronic instruments like GPS can fail, it's crucial to have a backup navigation method, such as using traditional sectional charts and a plotter. Advanced techniques for cross-country soaring. Successful cross-country soaring involves careful planning and keen judgment. Always maintain a constant awareness of landing spots within glide range, aiming to avoid situations where thermaling becomes necessary to reach a suitable landing area. To enhance cross-country skills, practice shorter triangle courses close to home, ensuring each leg remains within a few miles and scouting for alternate landing fields during the flight. When en route, estimating winds aloft can be challenging. Utilize winds aloft forecasts from AFSS before takeoff, then estimate wind speed and direction during flight using cues like cumulus shadow tracks or observed drift while thermaling. GPS devices can help compute winds aloft by measuring tush and ground speed. Mastery of glide calculator tools is crucial for approximating altitude needed to cover specific distances considering headwinds. Always maintain a safety margin. For instance, aim for an altitude of at least 1,500 feet AGL when nearing a potential landing area. Learning to read the sky for lift and sink is essential. Spend time in lift and swiftly navigate through areas of sink. Knowledge of your glider's performance under various conditions, such as lift, sink, and winds, is critical for effective decision-making during the flight. As you encounter thermals during the flight, recognize their influence on course correction and utilize them to maximize altitude for the journey ahead. Be prepared for altered glide paths due to changing thermal conditions. Understanding when to transition from thermaling to preparing for landing is pivotal. Depending on terrain and available landing fields, decide on a safe altitude to shift focus from soaring to landing preparations. Commit to the landing pattern once begun and avoid attempting to thermal again. A typical first cross-country flight can span around 50 kilometers, 32 statute miles, allowing for a gentle introduction to landing away from the home field. Prepare thoroughly, analyze available landing spots, and take off when confident. This experience, whether successful or not, is invaluable for boosting confidence and expertise in cross-country gliding. If you click like and subscribe and leave a comment, we will provide a coupon for a free PDF download, one of 9 ebooks. However, each individual can only download up to 1 out of 9 ebooks for free.